For the first three problems, we're looking to see if any input has two different outputs. The first one is a function because it passes the vertical line test. Number two, if we look at x, -2 shows up twice with two different y values, so that is not a function. Number three, every input has a unique output, so none of them repeat, so that is a function. For the next two, we're again looking to see if they have anything that repeats. That is a function, and our domain for the x values is -2, -1, 2, and 3. Our range, or the output values, are -2, 0, 6, and 8. For the next problem, if we look, we see that 1 has two different output values. 1 has the points 1, 2, and 1, -7, so that is not a function. The domain is -1, 1, and 2, and the range is -5, -7, 2, and 4. For the next two, we're going to use the vertical line test. If we draw a vertical line through 2 points, it is not a function, so here it fails in 2 different places, so that is not a function. The next one also fails the vertical line test, so another no. For the last two, we're going to write the domain and range. So for here, the domain is all real numbers, since we can use any value for x. And y is all the values of y greater than or equal to 0, which you can write 2 different ways. You can also write it as 0 to infinity. For the last one, the range is again all real numbers, since all x values can be used. And the range is going to be all values for y less than or equal to 3. Or you could say -infinity to 3. For these next two problems, we're going to graph an absolute value function. The vertex is at the opposite of h and k, so that is 4, since x minus 4 is our h value, and 1. Since it's positive, it opens up, and because the a value in front of the absolute value is 1, it's the same width as the graph y equals the absolute value of x. Pay attention to your scale here. We're going to start putting in points, so they start at 4, 1, and they go up 1 over 1. We'll connect the dots. So there's our graph. For the next one, there's nothing being added to the 0 inside the absolute value. So that means our h value is 0, our k is -2. So our vertex is going to be at 0, -2. This graph opens down because the a value in front of the absolute value is negative. And because it's a fraction between 0 and 1, it's going to be wider. So that flattens the graph a little bit. We start at 0, -2. We go over 3, down 2, and we connect our dots, and there is our absolute value graph. Now we move on to the review for ALT 3 and 4, which is our quadratics unit. We're going to start with x equals -b over 2a to find the axis of symmetry. That's also the x value of our vertex. We've got -2 for a, -4 for b, and 3 for c. So we plug that in, we get 4 over -4, which gives us an axis of symmetry at x equals -1. That becomes the x value of our vertex, so we're going to plug -1 back into the original equation for x. Make sure you square the -1 first and then multiply by -2. we've got 4 times negative 1 plus 3, which gives us negative 2 plus 4 plus 3, and we get a y value of our vertex of 5. So the vertex is 1, 5. I'm sorry, negative 1, 5. Next, we can do the y-intercept. So we're going to plug in 0 for x. You always plug in 0 for x to find y. That gives us the y-intercept on the graph. So the y-intercept is at 0, 3. Now we're going to find the x-intercepts. For this one, they don't cross right on a point, so we're going to plug them into the quadratic formula. Negative 4 plus or minus the square root of 4 squared minus 4 times negative 2 times 3, all over 2 times negative 2. We're going to simplify that. We end up getting 16 plus 24 underneath the radical over negative 4. We're going to simplify that. We get 4 plus or minus the square root of 40 over negative 4. We're going to pull out our perfect square factor. That gives us 4 plus or minus 2 times the square root of 10 over negative 4. If we simplify that, we get negative 1 plus or minus 1/2 times the square root of 10. If you calculate that out as a decimal, it's going to come out to 0.5811 and negative 2.5811. We can put those in as our x-intercepts. So our two x-intercepts will be 0.58, 0, and negative 2.58, 0. Because this graph opens down, we're going to end up with a maximum value. So let's plot our vertex. Because the a value is negative 2, we're going to go over 1, down 2, to the left 1, down 2, over 2, down 8, to the left 2, down 8. Connect our points. We have a maximum value at negative 1, 5, which is also the same as the vertex. If we put in our intervals, we've got negative infinity to negative 1, and then 1 to negative infinity. The graph is going up from negative infinity to negative 1, so that's our interval of increase. It's going down from negative 1 to infinity. That will be our interval of decrease. For number 2, we've got vertex form. This is similar to the absolute value, so the axis of symmetry is the opposite of our h value in there, x equals 4. Our vertex is at 4, 5. We're going to plug in 0 again to find our y-intercept. 0 minus 4 squared plus 5 is negative 4 squared plus 5. We're going to get 16 plus 5, so the y-intercept is 0, 21. We can plot some of those points now. We'll put a point at 4, 5 because the a value is 1 and it's positive. It goes over 1, up 1, to the left 1, up 1, and then left and right 2, up 4. We don't have any x-intercepts because it never crosses the x-axis. This time we have a minimum value at 4, 5. If we put in our intervals, we've got negative infinity to 4, 4 to positive infinity. We're going down from negative infinity to 4, so that's our decreasing interval. Positive 4 to infinity is our interval of increase. Our next graph we have in intercept form, or factored form. So our two intercepts are at negative 4 and 2. To find the axis of symmetry, we're going to add those together and divide by 2, which gives us negative 2 over 2, or negative 1. So our axis of symmetry, x equals negative 1. We have our two intercepts at negative 4, 0, and 2, 0. We find those by setting the factors equal to 0 and solving. We're going to plug the axis of symmetry in and get negative 1 plus 4 times negative 1 minus 2. That gives us 3 times negative 3, or negative 9. So our vertex is negative 1, negative 9. Again, we can plug 0 in for x in order to find the y-intercept. Y equals 4 times negative 2. So our y-intercept is 0, negative 8. Now we can start plotting our points. We can start at the y-intercept. We have our vertex. We can go over 1, up 1 again. Since a is 1, we're going to go over 2, up 4, over 3, up 9. Now we've got our graph. We have a minimum value at the vertex. If we put in our intervals, negative infinity to negative 1, negative 1 to infinity. So negative 1, negative 9 is our minimum, which is always the vertex. It's going down from negative infinity to negative 1. And we're going back up from negative 1 to infinity. The next graph is back in standard form. So we're going to start with negative b over 2a again. B is negative 6, so negative b is positive 6 over 2 times 1. Sorry, a little mistake there. 6 divided by 2 is 3. So our axis of symmetry is at x equals 3. Plug that back into the equation to find y. So we've got 9 minus 18 plus 7 gives us negative 9 plus 7. So our vertex is going to be at 3, negative 2. Plug in 0 again to find our y-intercept. So we've got 0 minus 0 plus 7. Y-intercept is at 0, 7. We're going to have to use the quadratic formula again for our x-intercepts. So we can put our points in there. Again, over 1, up 1, over 2, up 4, over 3, up 9. So we have a minimum value of 3, negative 2. Negative infinity to 3, 3 to positive infinity. We're going to be decreasing from negative infinity to 3. And we will be increasing from 3 to infinity. We can plug in the numbers to our quadratic formula, so that will give us 6 plus or minus the square root of 6 squared minus 4 times 1 times 7 all over 2. That reduces to 6 plus or minus 36 minus 28 over 2. From there we get 6 plus or minus 8 all over 2. We can reduce that to 6 plus or minus 2 times the square root of 2 over 2, and then reduce our fractions. So the intercepts are 3 plus or minus the square root of 2. You can leave that in radical form. We can write that as 3 plus or minus the square root of 2 comma 0. That would be both of our intercepts. We're going to change these last two into standard form. We've got vertex form and factored form. We're going to use the FOIL method on these. So that gives us x squared minus 2x plus 4 plus 6. We're going to multiply the 3 after we combine our terms. So now 3 times x squared minus 4x plus 4 gives us 3x squared minus 12x plus 12, and then add our 6 at the end. So our final answer is 3x squared minus 12x plus 18. For the last one, we're going to multiply out x squared plus 6x minus 2x minus 12. Distribute our 3 in our negative 3. And we're going to have negative 3 times x squared is negative 3x squared. Negative 3 times 4x is negative 12x. And then negative 3 times negative 12 is positive 36. Next, we're going to change standard form into factored form. So the first thing we want to do is pull out a negative 1, which gives us x squared plus 16x plus 28. Now we're looking for the factors of 28 that add to give us 16, which is going to be 2 and 14. So we have x plus 2 times x plus 14. Don't forget the negative 1 in the front. The next one, we're going to pull out a 3. So we pull the 3 out, we've got x squared minus 5x minus 6. We're looking for the factors of negative 6 that give us negative 5, so that's going to be negative 6 and positive 1. So 3 times x minus 6 times x plus 1. Now we're going to complete the square. So we're going to look for a new c value. Remember, you take x squared plus 10x. We're going to isolate that, put that in parentheses. We're going to divide the 10 by 2 and square it, which will be added. And then we're also going to subtract that outside the parentheses so we keep the equation balanced. 10 divided by 2 is 5. 5 squared is 25. So we've got x squared plus 10x plus 25 plus 23, and we're going to subtract 25 out here. Now we factor the parentheses. That's going to give us x plus 5 parentheses squared minus 2. So there's our answer for completing the square. We're going to do the same thing now for number 10. X squared minus 4x goes in parentheses. We're going to put the 9 out there. We're going to leave a placeholder for the part that we're adding and then the placeholder for the subtracting on the outside. We're going to divide negative 4 by 2, which is negative 2. Negative 2 squared is 4. We're going to add that there, and we're going to subtract it outside now to keep it balanced. Factor that out, and we get y equals x minus 2 parentheses squared plus 5. 11 through 20, we're going to use factoring, completing the square, or the quadratic formula. If you can factor, do that. For this first one, we're going to multiply a and c to get negative 4. Positive 4 times negative 1 is negative 4. Positive 4 times negative 1 is positive 3. We're going to use our shortcut method. Take the 2x and put our two factors underneath there and reduce, which gives us 2x minus 1 times x plus 2. To solve, we're going to set the equations or the factors equal to 0 and solve for x. So x is 1/2 and negative 2. For number 12, we're going to multiply 4 and 3 again to get 12. For our factors, negative 6 and negative 2, multiply to get 12 and add to give negative 8. Take our a term, write it as 4x over negative 6 and 4x over negative 2. Reduce those, and we get the factors 2x minus 3 times 2x minus 1. Set those equal to each other and solve, and we're going to get x equals 3/2 and 1/2. We'll try to factor number 13 again. We get negative 18, and we can get factors for that, negative 6 and positive 3. 2x over negative 6 and 2x over 3. Reduce those. We get x over negative 3 for the first one. That will factor to x minus 3 times 2x plus 3. Set those equal to 0, and we will get our answer of x equals 3 and x equals negative 3 halves. For number 14, we're going to move the 35 over. So we're going to subtract 35. That gives us 5x squared minus 20x minus 15. We can pull out a greatest common factor of 5. So that's 5 times x squared minus 4x minus 3. This cannot be factored, so we're going to use the quadratic formula. A is 1, B is negative 4, C is negative 3. Plug those in and we get 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 3, all divided by 2. We're going to simplify that. That gives us 28 underneath the radical. That reduces to 4 plus or minus 2 times the square root of 7 all over 2. And we can simplify that to 2 plus or minus the square root of 7. Number 15, we can't factor again. So we're going to use A is 1, B is 4, C is negative 2. Negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 2, all divided by 2. Reduce what's under the radical. You get 4 plus or minus the square root of 24. That becomes 4 plus or minus 2 times the square root of 6, all divided by 2. And we can reduce that to 2 plus or minus the square root of 6. For number 16, get everything over on one side. So we're going to subtract 3. That gives us negative 6 plus or minus, negative 6x squared plus 3x minus 1. We're going to plug in our A, B, and C. Reduce that, and we get negative 3 plus or minus the square root of negative 15 over negative 12. If you have a negative underneath a radical, we're going to pull the I out, which gives us negative 3 plus or minus I times the square root of 15 over negative 12. We can reduce that to 1/4 plus or minus 1/12 x, or 1/12 I times the square root of 15. Number 17, we're going to get everything on one side. So we're going to add 3x squared to get 8x squared. We're going to subtract 6x to get negative 8x minus 6 equals 0. Pull out a 2, and we've got 4x squared minus 4x minus 3. We can see if this factors. 4 times negative 3 is negative 12. We're looking for negative 4, so we get negative 6 and positive 2. Put the 4x over negative 6 and 2 and simplify. We get 2x minus 3 times 2x minus or plus 1. Set those equal to 0. 2x minus 3 equals 0, and 2x plus 1 equals 0. And for x, we get positive 3 halves and negative 1 half. For the last one, we're going to add 32, get everything on one side. So 18x squared plus 48x plus 32. We can pull a 2 out, which gives us 9x squared plus 24x plus 16. Since both of those are perfect squares, we can factor 3x plus 4 times 3x plus 4. Set that equal to 0, and we're going to get x equals negative 4/3. For the last one, we can solve with the square root method. We're going to divide both sides by 2. Take the square root, which gives us x plus 2 equals plus or minus 6. Subtract 2 to both sides. So negative 2 plus or minus 6 is going to give us negative 8 and positive 4. Number 20, we're going to add 49 to both sides. So 3x plus 2 squared equals 49. Take the square root and we get 3x plus 2 equals plus or minus 7. Subtract 2 from both sides. 3x equals negative 2 plus or minus 7. That will give us 3x equals negative 9, and 3x equals 5. So x is going to be negative 3 and 5/3. We can still solve with the square root method. So we're going to subtract 2. That gives us 24. Divide by 3 gives us x minus 3 squared equals 8. Take the square root of both sides. We get x minus 3 equals the square root of 8. Add 3, and we get 3 plus or minus 2 times the square root of 2. This one, divide by negative 2, and we get x minus 1 squared equals negative 18. Take the square root, which will give us x minus 1 equals the square root of negative 18. We can reduce that to 1 plus or minus 3i times the square root of 2. We're going to continue to solve. So with this one, subtract 2x from both sides. Subtract 13 from both sides. We get 3x squared equals negative 9. Divide both sides by 3, and we get x squared equals negative 3. The square root gives us plus or minus I times the square root of 3. For the next one, we're going to subtract 14. Divide both sides by 4, and we get x minus 4 squared equals negative 14 over 4. That reduces to negative 7 over 2. Take the square root of both sides. Then we can add 4, which gives us 4 plus or minus I times the square root of 7 halves. Number 3, subtract 20. And we get 2 times x plus 6 squared equals negative 20. Divide both sides by 2. X plus 6 squared equals negative 10. Square root of both sides. And our final answer is negative 6 plus or minus I times the square root of 10. Here we're going to distribute, so 2x minus 6 equals x squared minus 12. Subtract x squared from both sides and then add 6, and we're going to get x squared equals -6. Take the square root, which will give us plus or minus I times the square root of 6. The next one we can divide by -2. X minus 4 squared equals -11/2. Take the square root. We get -11/2. So x equals 4 plus or minus I times the square root of 11/2. And the last one, we're going to subtract 7. Divide by 5, which will give us x plus 2 squared equals -4/5. Square root both sides. X plus 2 equals the square root of -4/5. Subtract 2, and we have x equals -2 plus or minus I times the square root of 4/5. For these first 4 problems, we're just going to combine our like terms. 6 plus 2 is 8. 3i minus 7i is -4i. Combine here, we get 1 minus 11i. For number 9, we're subtracting, so we're going to change that to addition and then change the signs in this parentheses. -4 minus 3 is -7, -8i. 15 plus 10, and then -7 minus 3i. Next, we're going to FOIL. So 24 plus 12i minus 12i minus 6i squared. Remember that I squared equals -1. The 12i's cancel, so we've got -6 times -1, which turns into a +1, or +6. So our final answer is 30. Number 12, we're going to get the same thing. 6 minus 10i minus 6i plus 10i squared. Combine your like terms. Make sure that you turn the I squared into negative. So that's going to become a -10, which gives us -4 minus 16i. For the last ones, we're going to multiply by 3 minus I on the top and the bottom. We want the i's to cancel out on the bottom. So that gives us 21 minus 7i. We get 9 minus 3i plus 3i minus I squared, so the 3i's cancel. I squared becomes -1. So we've got 21 minus 7i over 10. Write it in standard form, 21 over 10 minus 7i over 10. Bottom here, we're going to multiply by 2 plus I. That gives us 12 plus 6i minus 8i minus 4i squared. I squared becomes -1, so we're going to turn that to a +4. The bottom, we get 4 minus I squared, so that's going to be +1. 12 minus 2i plus 4 is going to give us 16 minus 2i in the top. We're going to end up with 5 on the bottom. So 16 minus 2i over 5. Write that in standard form. 16 over 5 minus 2i over 5. For number 15, we're going to multiply by 4 minus 5i. That gives us 8 minus 10i plus 12i minus 15i squared. On the bottom, we get 16 minus 25i squared. So that will become +25. Combine your like terms on the top. 8 plus 2i plus 15. On the bottom we get 41. Combine your terms. 23 over 41 plus 2i over 41. For number 16, 8 plus 2i. That gives us negative 32i minus 8i squared. Bottom we get 64 minus 4i squared. That will turn into a positive 8 minus 32i over 68. We can reduce that to 2 over 17 minus 8i over 17. Now we have learning target 11, which is our solving systems. We're going to use substitution, so add 2y to both sides. We're going to substitute 6 plus 2y into the other equation for x. Multiply that out. We get 48 plus 16y plus 4y equals negative 4. Combine our like terms. 48 plus 20y equals negative 4. Subtract 48 to both sides. We're going to get 20y equals negative 52. And now divide by 20. Y is negative 52 over 20, which reduces to negative 13 over 5. Now you plug that back into one of our original equations. We're going to use x minus 2, substitute negative 13 over 5 in there, equals 6. That gives us x plus 26 over 5 equals 6. Subtract 26 fifths. And we get x equals 4 fifths. So our solution is the coordinate point 4 fifths, negative 13 fifths. Remember to write this as an xy coordinate point. For the next one, we're going to subtract 3x on the second equation to get y equals negative 3x minus 1. Substitute that into the other equation. 5x plus 2 times negative 3x minus 1 equals negative 3. We're going to distribute the 2. It gives us negative 6x minus 2. Combine our like terms. Negative x equals negative 1, so x equals positive 1. We can plug that back into the second equation. 3 times 1 plus y equals negative 1. Subtract 3 from both sides, and we get negative 4. So the answer is 1 comma negative 4. For elimination, we want to cancel out one of the variables, so we can multiply the second one by 2. Remember to multiply it by every term, so negative 4x minus 6y equals negative 8. Add our terms, the x's cancel, we get negative 4y equals negative 9, so y equals 9 fourths. Again, we're going to take that and plug it back into one of the original equations. If we plug it into the first one, we get 4x plus 2 times 9 fourths equals negative 1. 4x plus 9 over 2 equals negative 1. Subtract our 9 over 2. That gives us 4x equals negative 11 halves, and then divide by 4, and we get x equals negative 11 eighths. So our answer is the point negative 11 eighths, comma 9 fourths. Number 4, we're going to multiply everything by 3. Negative 6x plus 9y equals negative 12. The x's cancel. We're left with 5y equals negative 8. So y equals negative 8/5. Plug that back into either one of the original equations. If we use the first one, it's going to be 6x minus 4 times negative 8/5 equals 4. Multiply by the 4 gives us positive 32/5. We're going to subtract that to the other side. 6x equals negative 12/5. So x equals negative 2/5. So our answer is negative 2/5, comma, negative 8/5. 5 through 8, we can use whatever method we want. I think elimination is easier, so we're going to multiply negative 2. Negative 2 plus 4y equals negative 10. Everything cancels, so we get infinite solutions. For number 6, we can multiply the top one by negative 1 to cancel out the y's. Negative 5x minus y equals negative 16. We're going to get negative 8x equals negative 16, so x is 2. Plug that back in. Negative 3 times 2 plus y equals 0. Multiply that out, add the 6, and we get the answer 2, comma 6. Again, we can eliminate this one. Multiply the bottom one by negative 2. Gives us negative 16x plus 4y equals negative 14. The x's cancel, leaving us 9y equals negative 18. So y is negative 2. Plug that back into either equation. 8x minus 2 times negative 2 equals 7. Simplify 8x plus 4 equals 7. Subtract our 4, and 8x equals 3. So x equals 3/8. Our answer is 3/8, comma negative 2. For the last one, we can multiply by negative 3. That gives us negative 9x plus 15y equals positive 102. Add your terms. We get 19y equals 95. Divide by 19, and y equals 5. We'll plug that back into one of the equations. 9x plus 4 times 5 equals negative 7. 9x plus 20 equals negative 7. Subtract 20, we've got 9x equals negative 27, so x equals negative 3. So our answer is negative 3, comma 5. Next, we're going to move on to graphing inequalities. So remember, you're going to graph each of the 3 inequalities, and then we're going to shade based on the direction of the arrow. For the first one, we'll do in purple. So it's all of the x values equal to 4, so it's going to be a straight line through x at 4. Because it's greater than or equal to, it's a solid line, and we're going to shade to the right. The next one is all the values greater than 0 on the y-axis, so that's the horizontal line. Also solid line, it's shading up. The third line we have to solve, get y by itself. Subtract 5x, divide everything by 4. Our intercept is going to be at 10. The graph's going to go down 5 to the right 4. Down 5 to the right 4. We're going to put a solid line, and we're shading below, so it's to the right of the purple, above the green, and below the red, so it's going to be the little triangle. For number 10, we have to get y by itself. So for our purple line, we're going to subtract x. Y is less than or equal to negative x plus 3, so we start at 3, which is the y-intercept, and then down 1 to the right 1. We'll keep going down 1 to the right 1. Or you can go up 1 to the left 1. Again, a solid line, and we're going to shade below the line. For the next one, we're going to add 4x and then divide by 2. Notice here we don't have greater than or equal to, we just have greater than, so it's going to be a dashed line. Y is greater than 2x plus 1 half. 1 half is our intercept, and then from there up 2 over 1, up 2 over 1. Keep going up 2 over 1. Or you can go down 2 to the left 1. Connect your dots with a dashed line. We're graphing above, so it's below the purple, above the green, and so that's going to be that area to the left. Shade in the entire area. For number 11, we're going to get y by itself, so we're going to subtract 4x. Again, we've got less than, so it's going to be below the line, and it's going to be dashed. Start at our intercept of 1, down 4 to the right 1, or up 4 to the left 1. Again, dashed line, and we're shading below. For the second inequality, we're going to add x to both sides and then divide by 2. This one has the equal to, so we're going to draw the solid line. We get y is less than or equal to 1 half x plus 5. Plus 5 halves. Start at 2.5, and then we're going to go up 1 over 2. Or we can go down 1 to the left 2. We're shading below the line. And for the last one, we're going to subtract 2x and then divide by negative 3. Always remember that if you divide by the negative, it flips the sign, so it goes from greater than to less than. We get y is less than 2/3 x minus 2. We're going to start at negative 2. We're going to go up 2 to the right 3, or down 2 to the left 3. Fill in your points. Draw a dashed line because it's just less than. Now we're going to subtract 2x and divide by negative 1. So again, the sign's going to flip and go from less than or equal to greater than or equal to. We start at negative 8, and then up 2 to the right 1, or down 2 to the left 1. Solid line, and we're going to shade up. So above the green line, below the purple line, is going to be that section, the skinny section, down in the bottom left. Now we've got a straight line and a quadratic, so we're going to do a horizontal line through 5 on the y-axis, solid line, shading down, for the quadratic, we're going to find our intercepts and the axis of symmetry. Y-intercept, remember you can plug in 0, so 0, 8 is going to be our y-intercept. This one we can factor. We get x minus 4 times x minus 2. So our intercepts are at 4, 0, and 2, 0. So we can put in our y-intercept, we can put in our x-intercepts. We can find the axis of symmetry by adding the intercepts and dividing by 2. 4 plus 2 is 6, divided by 2 is 3. We can plug 3 back into the original equation to find y. Or we can use the factored form. So 3 minus 4 is negative 1, 3 minus 2 is positive 1. So our vertex is at 3, negative 1. We can plug that in. We go over 1, up 1 to our intercepts. We go over 2, up 4, to the right 2, up 4, to the left 3, up 9. Dash line, and it's greater than, so we're going to graph above the line, which is inside the graph. So we're below the purple line, inside the parabola, and so that's going to be this little section right here. For the next one, we've got another line, this time with a slope and another parabola. So we're going to do the same thing here. Start with our y-intercept, plug 0 in for x, we get 0, negative 3. For our x-intercepts we can factor x minus 3, x plus 1. So our intercepts are at 3, 0, and negative 1, 0. We can add those together and divide by 2. That gives us the x value of our vertex on the axis of symmetry, so x equals 1. Plug 1 into our factored form. One minus 3 is negative 2. 1 plus 1 is 2, so our y value is 4. 1, negative 4 is our vertex. We can go over 1, up 1, over 3, up 9. Draw in our graph. It is a solid line. We're shading below. For our line, we're going to start at 1 for the y-intercept, and then up 2 to the right 1, or down 2 to the left 1, dash line, and we're going to shade below the green line. So now we're below the parabola and below the green line. So that's going to be the section outside the parabola here, everything below the green line.